Hello everybody, my name is Autermann from 52 Degrees North in Münster, Germany, and I want to talk about the interoperable provision of research vessel tracking data via OGC, SensorThings API and Sensor Observation Service. This work is part of the EUROFLEETS Plus project, which aims to integrate and advance the European research vessel infrastructure. The project currently consists of 27 state-of-the-art research vessels, several ROVs and AUVs, and has multiple transnational access programs for researchers. Part of EuroFLEETS is the EVIOR portal, which stands for European Virtual Infrastructure and Ocean Research. And part of this is the dynamic vessel tracking and events system, which is currently a prototype. This is what it currently looks like. You can see the current measured navigational, meteorological and thermosalinity data of vessels and inspect previous cruises. And we wanted to replace this prototype with an implementation based on OGC sensor web standards. This is the overall architecture of the EVIOR portal. I won't go into much detail here because there's also a great poster about the data management in EuroFLEETS in general, also in this session. The following is just about how to get research vessel on-road data from EARS, the EuroFLEETS automated reporting system, which runs on the ship and on the shore, to the EVIOR portal. This is the architecture we are using for the actual ingestion of the data from the vessel to the sensor web services. The research vessels are equipped with the EARS system, which records the on-road data. The data is then transmitted to an onshore operator running an EARS server. This can be done via UDP, if the ship communication capabilities allow for that, but can also be done by other means. The EARS server offers an HTTP endpoint from which we are polling data in regular intervals. The feeding component then transforms these CSV structured datagrams into JSON entities of the SensorThings API and publishes them via MQTT. The data is then persisted into a database that is shared within Sensor Observation Service instance, and the extra dashboard to visualize the data is implemented using Helgoland, our generic sensor web client, which we've extended to also act as a client to the STA. As you can see, the dashboard also is able to subscribe to MQTT topics, which allows push-based visualization of near real-time data. Here we can see our dashboard, which is based on the generic Helgoland components. On the left side, we see live data where new observations arrive in near real-time via MQTT, and on the right side, we can see the visualization of complete trajectories of vessels. One major challenge was the harmonization of the different data models of SOS and SDA. The SOS uses SensorML and observation and measurements for structuring data, while the SDA has its own model, which is only parts based on the O&M standard. While quite similar, e.g. both have observations, observed properties, and feature of interest, the SDA introduces a new concept like the data stream, which we've mapped to the SOS offering. The observation process we are used to from the SOS is split into a thing and a sensor, and also these have now dedicated historical and current locations. We wanted to do the ingestion only via the SensorThings API, so after initially setting up some entities via HTTP, we only want to feed via MQTT. For this, we had to allow publishing on more topics than the standard allows, e.g. locations and not only observations. We mapped the entities of the SOS, namely the procedure and offering, to the SDA entities like the sensor and the thing. So these are the same. Our observation should comply with the spatial filtering profile. For this, the SDA implementation was extended to recognize this parameter. The position update should be appended to the feature of interest so that the feature contains the complete track. For this, we also created extension for the SDA, so every time we push a new observation or a location which contains a coordinate, the coordinate is appended to the feature of interest. Originally, we wanted a feature of interest per cruise, but unfortunately we cannot really determine which is a cruise, so for now we have a feature of interest per week. EARS has the capability to record event data, for example, sensor calibrations or start and end of measurement series. These are encoded as SensorML with several events per day, and we found that updating the SensorML description in the SOS does not scale. So we created a new observation type with a SensorML event as a result value, and we are now handling the event data the same way as the measured data. As an outlook, we would like to deploy the software to more RV operators. Right now it runs only as CSRC in Spain. We would like to enable the EVIOR portal to use multiple SensorThings APIs in the backend. Right now it's restricted to only a single instance. We would like to have a push-based data flow from the EARS software to the feeding component. Right now it's HTTP pulls, and that's not really real-time. We would like to have richer metadata descriptions. Right now the SensorML descriptions in the SOS are auto-generated from the SensorThings entities, and we would like to add visualization of event data. Thank you very much, and if you want to know anything in more detail, please get in touch with me.